Go language programming, chapter 7, unit 6. In this unit, we will cover channel overview in Go language, use make function to create a channel, and channel usage. So basically, let's look into what the channel is. So channel is a type in Go language, and therefore no need to import any standard library packages. Like when we were talking about uh, uh, synchronizing the goroutines using the sync package. Uh, there is no package involved in using the channels. So channel is an important built-in feature that Go language provides. Mainly, it acts as a concurrency synchronization technique for the Go routines. Okay? So that is the whole idea behind using the channels to make the Go routine communicate. So the channel acts like a pipe between the Go routines, or a pipeline between the Go routines. So channels are used as a way to transport data from one end to the other end. So that means channels are treated as a FIFO, first in, first out queue, because you put the data in, you send the data, and on the other end of the channel, you receive the data. Okay, so it acts just like a queue. So on one end, goroutine sends the data over the channel, and on the other end of the channel, different goroutine receives the data from that particular channel. Okay? So that's the way that the data is transported between the channels. So let's look at into more detail here in the class notes. The channels allow goroutines to communicate between each other by sending or receiving values to one another. Okay, so that's how they communicate. So channels are designed to synchronize by passing values between goroutines, and in concurrency, synchronization is the most important part. So that way, in this case, since we are using a Go routines, which are basically running independently, and if they are not synchronized, they could run into race conditions. So the synchronization is very important when you're doing the or when you're writing the application that is needed, the concurrency. So channels are reference type, just like a map. Okay, what it gives us is when you pass a channel as an argument to the function or a method, you are passing the channel as a reference. So that means you are transporting some values on that particular channel, which is passed to the function or a method, and when the call return back to the caller for the function, the values on the channel will be, if they're changed, then they will be retained. So that's why they are not considered as a pass by value. On the other hand, which we talked about it in previous chapters about the slices. Slices are passed by value. Okay, so in that case, the slice, if it has some data that is appended to the slice, then that appended data would, when the function returns to the caller, that would not be seen by the caller of that function. So basically, that's why slices are passed by value, unless of course you pass the slice as a pointer. Um, so channels can be compared with equality sign, the two equal signs, if they are of same type. So you are allowed to compare the channels between together, to find out what is on the channel. uh, Channels have two operations, you know so you send the something over the channel on one end, and on the other end you receive something from the channel. Okay, so that of course would be considered as sending it from one go routine and receiving it on the other go routine over the channel. Channels have several characteristics. Basically, that means that you can create a channel of type of the data that it will take, meaning that you can have a channel that will take integer type data, or a string type data, or struct type data. Okay, so so you it's the way that when you create a channel, you have to decide what type of a data is going to go over the channel. And if whatever the way that you created the channel, that is the specific type of a data that you can transport it over the channel. You cannot mix it with, like, you created the channel with a integer type, and then you decide, oh, I want to have a string going over, or transported over the channel. That's an error condition. You can also create a channel, either unbuffered channel. Okay, that means there will be um, uh, no more than one item in the channel, and or you can create a buffer channel. That means you are giving the channel a capacity that it can only have certain amount of items in the channel. So in the queues, remember, we just talked about the channel is considered as a queue. So the queue size will be depend upon how big of a buffer that you have when you create the channel. So you can have a either a unbuffered channel. That means you will have only one item on the in the channel, and as long as that item is still there in the channel, then that item must be removed by the receiving side. Okay. Same, of course, same thing applies if you create a buffered channel. We will go over both unbuffered and buffered channel pretty soon. the direction of communication. So, it depends upon which direction that you want to communicate over the channel. You can have, based on that, you can have it either the send or receive, and we will see how that is done. Basically, it is done with this uh, arrow, when which direction the flow will happen of the data. So all of the above feature can be specified by using a built-in channel operator. So basically, this operator, arrow operator, will allow you to decide which direction the channel will be flowing. So arrow operator indicates which direction the channel flows, either towards the read or towards the write. You know, so based on that, you will know the direction of the data will be flowing. Uh, you can change the direction of the channels by adding the arrow before or after this channel keyword. CHAN is a keyword in Go language to create a channel. So depending upon what side this arrow operator is it the arrow operator is on the left side of this keyword CHAN, or it is on the right side. That's how the directions are decided for the data to flow. It is possible to create a bidirectional channel. So, bidirectional meaning the data could be flowing in either direction, on that particular channel. So, as well as unidirection, meaning that you decide by using this arrow operator which direction the flow will flow of the data will be happening, or which direction the transportation will be happening. And so basically, the receiving side will receive the data, and sending side will be sending the data over the channel. And so that you can do it either, when you create the channel. So direction of the arrow determines if the channel is send data or receive data. So basically, the arrow is the one which will tell us. So let's look at it. When you create a channel, if you want to use that channel as a bidirectional, you don't have the arrow. Now this, of course, you have to remember, this will have to be done at the time when you are creating a channel. So in this case, there is no arrow operator on either side of the this keyword CHAN. If you wanted to have the data to be written on the channel, then you use this arrow keyword on the right side of the keyword CHAN. Okay, that means you want to write something to that channel, and that's how you want to create. So that particular channel will only be taking in on that direction. So that means you can only write the data to that direction, to that channel. If you have an arrow operator on the left side of the keyword CHAN, then that means you are going to use that channel only for the reading purpose. Okay, uh, so that means input, as an input channel. So this is the only key thing that you have to remember: which side this arrow will go, either on the right side for writing, or on the left side of a keyword chain to for the reading purpose. So placing the arrow operator after the channel, which means right here, um, after the keyword channel, which means this one. Okay, uh, the keyword makes the channel write only. Okay, so if you do that way, then that means that channel will become only write only. You can write to the channel, you cannot read from that channel. So a channel to which we can only send data. Okay, so in that case, basically, once you created the channel by using this, then you want to send some values to write something. So this is how you will write the data to the channel name, whatever the name of the channel that you created for. So we will see these examples very soon, so you will have a little better idea how the reading and writing from the channel works. Placing the arrow operator before the chain, that means before the chn right here, it makes the channel read only. Okay, so that means you can not write to that channel, you can only read from that channel. Okay, and to read from the channel, you have the channel name. Okay, that means it's just like a pipe, and something coming out from that pipe, and you are saving it into some variable, that you have. So the data will be saved into this variable. Okay, so you are reading it. Sending and receiving from the bi-directional channel. So if you create a channel bi-directional, as you can see, there is no arrow involved in here during the creation of the channel. Okay, and the channel will take the integer type values only. Okay, you cannot, when you create and you say, okay, it will be the int, then that means it will be the int type. And now once the channel is created, then you can either read or write, because it's a bidirectional channel. So in this case, if you are reading it, then on the left side of the channel name, that is a variable of that channel type, then that means you want to read something from that channel. Okay, and if you are writing it, then that means you have to uh, give the data on the right side of the arrow to the channel name. So that means you are writing the data on that channel. Okay, so the arrow operator is the one which tells you the direction of the data, which direction the data is going to be, and it also allows you to be able to treat the channel as either the read for the read purpose or the write purpose. So now let's look at how actually you create a channel by using a make function. Okay, so you use a make function just like the way that we use the make function for creating the maps, for example. You use the make function to create a channel. So channel must be created before they are used. Okay, and you have to use a make. So there are two kinds of channel: uni unbuffered channel and buffered channel. Okay, so make function allows you to create either one of them, either a buffered channel or unbuffered channel. Buffered channel will have a capacity, how big of the buffer that you want for the channel. uh, Unbuffered would not have a capacity. Okay, so basically that means the data goes to the channel and gets out right away. So that's how the channel will be operating. So create an unbuffered channel that takes an integer and sets it to 0 by default. So as you know, Go language, does the initialization automatically. We do not need to explicitly initialize anything when you create. If you create a variable of type integer or a string, they will always be initialized to, the integer type variables will be initialized to 0, for example. So to create an unbuffered channel, you use a make function like this. In this case, we have a int type of a channel. So that means this channel will be taking the only int type data. So channel is just nothing but like a queue. So in this queue there will be a only one item queue. This will be because this is unbuffered channel, so there is no buffer involved. So we will see how the buffer channel is created in a second. um, so you have num is the name of the variable, or num is a channel type variable that gets created, because we are using this short initialization colon equals to. So the make function will create a channel, okay, and assign that channel to this variable called num. So num is of type channel variable. Now, if you want to send something, because this is a bidirectional, so you can send some data on that channel. So you just use the this arrow operator, and on the right side of the arrow operator, you give the data that you want to send to the channel. And if you want to read something from that channel, in this very simple example, we want to read from this channel called num. Okay, so the arrow will go on the left side of the name of the channel, and that means you want to receive. Okay, in this case, if you just do it like this, you are just receiving it. And if you would use this in a print line, to print what values are there, it will print those values. Of course, a print line is in FMT package, so you use that function to print out what values this channel has, and it will show it. Or you can use something like this, d colon equals to. So that means the value which is in this channel will be saved into this variable d. Okay, and that variable is going to be of type integer automatically. It's not going to be of uh, type channel. It will be, because channel is this, and in this case we are just extracting the values from the channel and putting it into the some variable. So the variable will be created of type int, because the channel that when we created, it was of type int. Okay, so in actually right here, this is the example that I have it in the notes. So in this case, whatever the values are in the num channel, they will be saved into the result. Okay. Um, let's look at how the Boolean channels are created. So a Boolean channel that is read from only. Okay, so you can only read. So the way that, to do that, when you create a channel, so we are creating a channel by using a make function. Okay, and you pass the make function that, okay, we want to create this channel for read purpose only, or receiving purpose. So basically, if you put the arrow operator on the left side of the keyword channel, that means you want to be able to read only. So now, this channel name is flag CHAN. Okay, so that is the name. So that channel will be only used for the reading purpose only. In this next example, we are basically saying that we want to create a channel, right channel, meaning sending, and we want to create the channel type will be a slice. Okay, type. But notice the arrow is on the right side of the keyboard channel. That means you want to be able to send the data or the slice over this channel. So you are going to be sending the whole slice over the channel. You can create a buffered channel, which we'll cover in little detail about the buffered channels, by providing the capacity. So this is the capacity right here. Okay, the size of the buffer, how big of a buffer for the channel. So basically, channel is nothing but like a queue that we talked about earlier. So the reason that we say that channel is just like a queue is because on one end you put something, and on the other end you take it out from that queue. Okay, or you can even consider thinking about the channel as a pipe, pipeline. So on the one end of the pipe, put some water, and it will come out on the other end. So basically, and the reason that you do this is to make sure that the go routines on either end of the pipe can communicate between each other. Okay, so that's why the channels are used for the communication of the go routines. So a channel that takes another channel as a value. So you can even, so in the previous example right here, we were doing, either like a bool, the simple way to create the channel. Okay, you can actually have the in this case we are creating a channel which will be ascending. Okay, so we are sending, creating another channel which will go over this channel. Okay, but it will be sending. So data is sent. So one channel has a data, and that channel will be passed to another channel. Okay, so that's how. So you think about it like a pipe inside the pipe. Okay, so that's how this is created. Channel usage. Channels are first class elements in Go language, and therefore they can be used almost anywhere. Okay, so you can use it as struct fields. Okay, so that means you can create a one or multiple struct fields of type channel. You can pass the channel as a function arguments, or you can return a channel from a function, okay, by using a return statement. um, or use other channels, so you can utilize the other channels as well by for the channel. So channel inside the channel, just you can think in that term. Passing channel type, to a function. So this is the way that you will pass the the channels to the function. So a function called in channel, okay, that you have a parameter of that function must be declared this way, meaning that this arrow operator would be on the left side of this keyword CHAN. Okay, so that means you are you are creating this parameter which will only allow you to write. So you write to this parameter, to this string, and so if you want to do that, then you basically have to have a this arrow operator on the left side of the this keyword CHAN. If you want to have the read um, channel as a parameter, then you need to have the arrow operator on the right side of the keyword chain. Okay, so that will give you the read capability for that parameter. If you want to have the bidirectional, uh, uh, so you are creating a function called two-way, and in that case you don't have any arrows operator on the either side of the keyword. That means you want to create you want to have the parameter for the channel that could be used for either reading or writing. Okay, but this is the way that you have to understand how to pass the channel to the functions. So a function can return a channel. You can, create a, or you can return a channel from the function. Same way as you have seen it returning some values from the function. So you have the function name. This function does not have any parameter list, so this list is empty, but it does have a return value. So the return value of is of channel type, so that's why we have right here. And then within the function body, we we are creating a channel by using a make function. So we create an int type channel, and then once the channel is created, we are returning it with the return statement from within the function body. So that's how you can return a channel. Create a bidirectional Boolean channel without specifying the buffer. Okay, so this is basically we are creating the bidirectional channel. So in that case, it will be used for both reading and writing, or sending and receiving. So that's how you create a bidirectional channel. So let's go and see some examples in the next page, how all these things can be used in the code. So first of all, the goroutines writes true to uh, to done the channel if you are passing the uh, the uh, channel type parameter to a function. So you can do that within the body of the function. And in the main function, you wait for the value to be passed. And that's what we are going to go over this function so you can understand that, how the go routine is communicating with the main go routine. Okay. So basically, what we are saying that from the function, you when you have a done channel, you the channel either could have either a true or false, and then it will be used within your main go routine. So program will only end after channel reads a value from the go routine. Okay, so that means until it reads, your main go routine is blocked. Okay, it is not going to stop, meaning it would not terminate. Okay, so that's because we want to make sure that the go routine, which is called from the main go routine, or which is started from the main go routine, get a chance to finish. And for that reason, we are using the parameter in the this function. So let's look at the code now. This code in example 710 is really same code as we used it in example 7-3. Okay, in that code, we were blocking the main go routine by using a sleep call from the time package. Okay, that's how we were blocking. But in here, in this example, that's the only thing is changed. Otherwise, rest of the code is exactly same. So in here, we are of course using a channel to block the main go routine to terminate. Okay, and the way that it will happen is we call this show message function by starting the go routine. Okay, show message and passing the channel, because this message this show message function is taking the parameter of type channel. Okay, and the boolean type parameter basically. So when after we create a channel at line number 13, um, the channel name will be done. Okay, that will be the name of the channel, and we are passing the done to the show message, because the show message is taking the parameter of type channel. Okay, on the boolean channel basically. And then basically, when we come to this line number 17, your main go routine is blocked, because done hasn't gotten any signal from the show message function. So it basic idea is that as soon as this will become true, then it would not be blocked anymore. Okay, um, and it will print out the message from here. Okay, the message from here and message from here. So basically, what will happen, the as soon as you start the program, it will first print out this main started. That's what it is going to do. And then in the main started, at line number 13, we are creating a channel called done. Okay, it's a Boolean type channel. So the channel is created, and then we execute the go routine. The go routine name is the show message, and we pass the done to it. So now, in the background, the show message go routine is running. Now, when it is running, that means in within this body of this function there is a print line. So it will print hello world. So first it will print main started, and then it will print hello world. Okay, because it will get the chance to finish the printing of this message. And as soon as it is done, it will send the true to this channel. So when the true comes right here at this channel called done, then that means the main go routine will no longer will be blocked, because as you can see, this message is coming from the go routine which is running, and that is the one go routine which tells the main go routine, hey, I'm done now, you can finish the program, or you can terminate. Okay, so that's the whole idea about the blocking that we've been talking about. So in this case, we blocked the main go routine by communicating with the go routine called show message. Okay, so that's how we blocked it. And as soon as the show message go routine says, oh, okay, I'm done, then the main go routine will terminate. Okay, so that's how most of the time channels are used for communicating between the go routines. So that's about it for Unit 6, Chapter 7. So